Hello and welcome to the second module on conveyance and transport technologies. In the last presentation, we took a closer look at container-based technologies and got a glimpse into manual and motorized emptying of on-site sanitation systems. We will now look at the different types of sewer systems. We distinguish between three categories of sewer systems: the simplified sewer system, also called shallow or condominial sewer system; the solids-free sewer system, also called settled or small bore sewer system; and the conventional gravity sewer system. Basically, the differences between the three systems can be summarized in terms of the size, the depth, and the slope of the pipes. Let's have a closer look at these three systems. The best known system is the conventional gravity sewer. Conventional gravity sewers are large networks of underground pipes that convey black water, grey water, and in many cases storm water from the houses to the wastewater treatment plant using gravity and often pumping stations. The sewer is designed so that it maintains self-cleansing velocity, which means guaranteeing a flow that will not allow particles to accumulate. Access manholes are placed at set intervals above the sewer, at pipe intersections, and at changes in pipeline direction. When the sewer also conveys stormwater, which is known as combined sewer, sewer overflows are required to avoid hydraulic surcharge of the treatment plant. However, nowadays, a separate drainage system for rainwater or local retention and infiltration are recommended instead, which leads to cheaper and more efficient systems. Conventional sewers involve less maintenance than the other systems, but are very expensive and request major works, like shown here in Egypt. Their costs can reach often more than 60% of the cost of the entire sanitation systems, the treatment plant included. Operation costs may be high as well, depending on the pumping requirements. For this reason, it is often a too expensive and capital-intensive option for low-income contexts. Wherever possible, simplified sewer systems should be preferred, as it is 20 to 50% less expensive than conventional sewers and much easier to implement. The simplified sewer describes a sewage network that is constructed using smaller diameter pipes, laid at a shallower depth and at a flatter gradient than conventional sewers. Simplified sewer can be installed where there are no heavy traffic loads, for example, within a condominium, in narrow alleys, or underneath sidewalks. Thus, they allow for more flexible design at lower costs. Some of the main differences with conventional sewers are the minimum depth, which is about 30 centimeters instead of 80, the minimum gradient, which is about 0.5% instead of 1%, and the minimum diameter of the pipes, which is about 100 millimeter instead of 2 to 300. Another important difference is that expensive manholes are unnecessary. Instead, simple inspection chambers or cleanouts are sufficient. Inspection boxes are also built for each house connection. Simplified sewers are especially appropriate for dense urban areas where space for on-site technologies is limited, such as on this picture. The drawback of the lower gradient and diameter of the pipes is that repairs and removal of blockages are more frequent. However, this can be done easily by locals at little cost. Such a system can be operated by the community itself. It is important that the users avoid disposing trash or other solids into the system. In all cases, occasional flushing is recommended to ensure against blockages. The last option is the solids-free sewer system. As its name indicates, the specificity of the system is that solids are separated before entering the sewer system itself. This is done at house level, for example with single-chamber septic tanks. Removing the solids dramatically reduces the risk of deposition and clogging. Thus, there is no need for a minimum flow velocity and for a minimum slope. The system can even bear negative slopes, as long as the downstream end is lower than the upstream end. A minimum diameter of 75 millimeters is required to facilitate cleaning. Stormwater must be excluded in this system. The critical point is, of course, not to let solids in. For that purpose, it is very important that the interceptors are regularly dislodged. Solid-free sewers are the least expensive of all sewer systems. However, it requires good training and acceptance by the users. Otherwise, the risk of failure is high. The choice of the appropriate sewer system is a trade-off between the price and the maintenance requirements. Conventional sewers lead to little maintenance problems. However, their price is often prohibitive. On the other hand, simplified and solid-free sewers are much less expensive, but request more inputs from the users. In summary, the conveyance technology choice generally depends on the following factors: the type and quantity of products to be transported, the distance to cover, the accessibility, topography, soil and groundwater characteristics, the financial resources, the availability of service providers, and management considerations. To conclude this module on conveyance technologies, it is important to note that if sewer systems are often seen as the gold standard target to reach, it does not always make sense to use water to convey excreta in sewers, especially in water-scarce areas. Non-sewage systems are sometimes the best option. In the next module, Christophe Litty will sum up the learnings from the week. As for me, I will join you again for the treatment technologies. See you then!